All right, Unit 3, Day 4 is going to be about systems word problems. So here are the steps to solving word problems using a system. Number 1, decide what the problem is asking you to find and define your variables, which means that you need to write down what your variables are standing for. So for example, let X be the number of tickets sold. Step 2, use the information given in the problem and your defined variables to write a system of equations. Make sure both sides of your equations are speaking the same language. So for example, if the left-hand side is talking about number of tickets, the right-hand side must be talking about the same thing. Or if the left-hand side is talking about the price, the right-hand side must talk about the price as well. Number 3, solve the system by graphing, substitution, or elimination. We're not going to use graphing. We're either going to be using substitution or elimination to solve the system. Step 4, make sure your answers make sense and label your answers with the appropriate units. So if the problem is talking about the number of tickets and you get a decimal for an answer, it wouldn't make sense to have a decimal when a ticket is countable, right? It should be a whole number, and it shouldn't be negative at all, right? Because it's a physical object. So let's take a look at example 1. Your teacher is giving you a test worth 100 points containing 40 questions. There are 2-point and 4-point questions on the test, which means that there are certain questions worth 2 points each, and there are certain questions worth 4 points each. How many of each type of question are on the test? Now, if we look very closely at the last sentence, it's asking us to figure out how many 2-point and 4-point questions are on this test. Now, what I like to do first is define my variables. We're going to let X represent the number of 2-point questions. And we're going to let Y represent the number of 4-point questions. Now, after you define your variables, what we're going to do next is determine the total numbers, meaning that we need to look at the first and second largest numbers stated in this problem. So the first largest number that I see is 100, and the second largest thing that I see is 40. So I'm going to go ahead and write totals and write my first largest number, which is 100, which deals with points, and my second largest number, which is 40, dealing with questions. So we should have an equation dealing with points, and we should have an equation dealing with questions. Now, what I'm going to do is I'm going to write my system of equations. Again, we need to have an equation dealing with questions. So the total number of questions is 40, and my second equation dealing with points, and the total number for that is 100. So again, we're going to write an equation dealing with questions and points. So looking at the first equation over here, we have the right-hand side, we have the total, but we don't know what to put on the left-hand side. If we're talking about questions, do we know how many 2-point and 4-point questions there are on this test? No, that's exactly what we're trying to figure out, right? But we've already defined the variables. We've already defined the X and Y. X represents the number of 2-point questions, and Y represents the number of 4-point questions. So if we write X plus Y, then that should equal to 40 questions in total. Now, looking at the second equation, we're dealing with points. There are 100 points in total. And we can see that there are 2-point and 4-point questions on this test. So I'm going to write 2 plus 4. Now, 2 plus 4 is not 100. So we're definitely missing some things here to make the equation true. And we know that there are certain questions worth 2 points each and certain questions worth 4 points each on this test. So instead of just writing 2 and 4, I should say 2x and 4y. Now that makes sense because I can read this as you will get 2 points for every question that you get right, plus 4 points for every question that you get right, and the total maximum number of points that you can receive on this test is 100. So I've already created my system. We have x plus y equals 40 and 2x plus 4y equals 100. So all I need to do right now is solve this system and determine how many of each type of question are on this test. So we have our system of equation. We have x plus y equals 40 and 2x plus 4y equals 100. Now, All what we need to do here is just solve this system. You can use substitution or you can use elimination. I'm just going to go ahead and eliminate my x's. So I'm going to multiply the first equation by -2 so I can create my opposite, something that we talked about in the previous lesson. So I'm multiplying the first equation by -2, and I'm going to distribute that -2 to each term. So I should have -2x minus 2y equals -80. And then I'm going to rewrite that second equation. So 2x plus 4y equals 100. And remember, the goal for elimination is to find your opposites before you solve. And we do have our opposites in terms of our x's, right? -2x and 2x will cancel out. And then I can go ahead and add vertically. So -2y plus 4y is 2y equals -80 plus 100 is 20. So if I divide both sides by 2, y is equal to 10. We're not done yet. We have our y value. We need to figure out our x value. So what I'm going to do is I'm going to take my y value and plug that into the first equation here, that x plus y equals 40. So you're going to need some more room for this, but I'm going to write x plus 10 equals 40, and I'm going to subtract both sides by 10. So therefore, x is equal to 30. So what does this all mean? We have 30 2-point questions and 10 4-point questions. And that makes sense because there are 40 questions in total, so 30 plus 10 equals 40. So these two are your answers. Number 2, the math club and the science club had fundraisers to buy supplies for a hospice. The math club spent $135 buying 6 cases of juice and 1 case of bottled water. The science club spent $110 buying 4 cases of juice and 2 cases of bottled water. How much did a case of juice cost and how much did a case of bottled water cost? So what we're going to do first is to define our variables. Let J represent the cost of juice. And let W represent the cost of water. And the next thing that I'm going to do is determine my totals. So we need to figure out the first largest number and the second largest number. The first largest number that I see right now is 135. And that's dealing with money. And the second largest number that I see is 110, also dealing with money. So your first equation should be dealing with money, and your second equation should be dealing with money as well. So I'm going to write equals 135 for my first equation and equals 110 for my second equation. So if I look very carefully at the word problem, it says the math club spent $135 buying 6 cases of juice and 1 case of bottled water. So I'm going to write 6 plus 1. But we all know that 6 plus 1 is not 135. Right? So we're actually missing something. So we need to go ahead and write our variables in. We know that J represents the cost of juice and W represents the cost of water. So it's 6 cases times the cost plus 1 case times the cost. So I should write 6J plus 1W, which is equal to 135. Now, for my second equation, the science club spent $110 buying 4 cases of juice and 2 cases of bottled water. So I should write 4J plus 2W. All what we need to do is solve for the system. You can solve this system by using substitution or elimination. Like I did last time, I used elimination. So I'm going to do the same thing for this problem. So what we need to do is create our opposites. I'm going to eliminate the W's this time. So I'm going to multiply the first equation by -2. And then I'm going to distribute the -2 to each term. So -2 times 6J is -12J. Negative 2 times 1w is negative 2w, and negative 2 times 135 should be negative 270. And I'm going to go ahead and rewrite the second equation. So 4j plus 2w equals 110. I can see we can cancel out our w's. And now I'm going to go ahead and add vertically. So negative 12j plus 4j is negative 8j equals negative 270 plus 110. That is going to be negative 160. So if I divide both sides by negative 8, j is going to be 20. So now what we're going to do is we're going to take what j is and plug it into one of my equations. I'm going to use the first equation to figure out what w is. So if j is 20, then 6 times 20 plus 1w equals 135. 6 times 20 is 120. Plus 1w equals 135. And then I'm going to subtract both sides by 120. So w equals 15. So that means it costs $20 for a case of juice, and $15 for a case of water. All right. Number 3. Rod has 40 coins, all dimes and quarters, worth $7.60. How many dimes and how many quarters does he have? So the goal here is to figure out how many dimes and how many quarters this person has. But the first thing that we need to do is define our variables. So we're going to say D represents the number of dimes, and Q represents the number of quarters. So once you define the variables, you need to figure out the totals. So we need to figure out the first largest number and the second largest number. The first largest number is 40, dealing with coins. And the second largest number is $7.60. Of course, dealing with money. So you should have an equation dealing with coins. So the total should be 40 coins. And the second equation is dealing with money. So it's $7.60. So if we look at the first equation, we have 40 coins. But we don't know how many dimes and how many quarters there are. We did say that D represent the number of dimes and Q represent the number of quarters. So I can say D plus Q equals 40. Now for my second equation, we have $7.60. We do know that a dime is worth 10 cents and a quarter represents 25 cents. So I will write 0.10 plus 0.25. But this doesn't make sense because 0.10 plus 0.25 is 0.35 or 35 cents. That's not $7.60. So we are missing some things. We are missing our variables. So if we write 0.10D plus 0.25Q, then that makes sense and should equal to $7.60. Because what this is saying is that it is 10 cents per dime and 25 cents per quarter, and that is going to equal $7.60. So we have our system, we have our first equation, and we have our second equation. What we need to do is we need to solve the system. We need to figure out, again, how many dimes and how many quarters this person has. So what you can do is solve this system by using elimination or substitution. We've done elimination for the first two problems. We're going to go ahead and change it up for this problem. We're going to solve this system by using substitution. If we look carefully at the first equation, D plus Q is equal to 40, what I'm going to do is I'm going to solve for one of the variables, meaning I need to let D or Q be on its own on one side of the equation. I'm going to solve for the number of dimes, which is D. So I need to get D by itself. So how do I do that? I need to subtract both sides by Q. And I get D equals 40 minus Q. So that means, since we have D equals 40 minus Q, I don't need this equation anymore. All right? So since I'm using substitution, if D is equal to 40 minus Q, then I can replace this variable, this D, with 40 minus Q. So I can say 0.10 times 40 minus Q plus 0.25Q equals $7.60. And then I can go ahead and apply the distributive property. So 0.10 times 40 should be 4. And 0.10 times negative Q should be negative 0.10Q plus 0.25Q equals 7.60. And then I'm going to combine the like terms here. We have negative 0.10Q plus 0.25Q. That is 4 plus 0.15Q equals 7.60. And then I'm going to subtract both sides by 4. And I'm going to need more room for this. So I have 0.15Q equals 7.60 minus 4. That is 3.60. And then I'm going to divide both sides by 0.15. So Q equals 24. So there are 24 quarters. So I'm going to write there are 24 quarters. But I'm not done yet because I need to figure out the number of dimes. So if Q is equal to 24, and we have this equation here, I can figure out the number of dimes that way. So D equals 40 minus Q, or D equals 40 minus 24. And 40 minus 24 is 16, so there are 16 dimes. All right. Number 4. Tickets for a concert cost $8 for adults and $4 for students. There were 120 more adults than students that bought tickets, and $5,760 worth of tickets were sold. How many adult tickets were sold, and how many student tickets were sold? So again, we need to define our variables. So let A represent the number of adult tickets. And let S represent the number of student tickets. And then after that, we need to figure out our total. So what's the first largest number and the second largest number? So the first largest number that I see is 5,760, which is in dollars or money. And the second largest number is 120. Now, I need to be very, very careful with this one, because it actually says 120 more adults than students, right? So what I need to do with this number, since it says 120 more adults than students, I need to figure out what that means. It means that to figure out the number of adults, there are 120 plus S, which is the number of students. All right? So that is actually our equation there that we can use for our system. So we should have an equation dealing with money. So the total is 5,760. And then our second equation is already figured out, right? The number of adults is equal to 120 plus the number of students. So, looking at the first equation, because we're not done yet, we need to figure out how to write our equation for that one. It says tickets for a concert cost $8 for adults and $4 for students. So I can write 8 plus 4, but we all know that 8 plus 4 is not 5,760. So what's going on here? We're just missing the variables, right? So let's go ahead and include our variables. So it's 8a plus 4s. And then we have our two equations here. We can solve this system by using elimination or substitution. I'm going to use substitution like I did last time because look, if the number of adults is equal to 120 plus s, then I can replace this variable, a, with this expression. So I can do 8 times 120 plus s plus 4s equals 5,760. And I distribute the 8 to each term. So 8 times 120 is 960. And 8 times s is 8s plus 4s equals 5,760. And then I can go ahead and combine the like terms here. So 8s plus 4s, that is 12s. So 960 plus 12s equals 5,760. And I'm going to subtract both sides by 960. So 12s equals 5,760 minus 960 is 4,800. So if I divide both sides by 12, the number of students is 400. So there are 400 students, but we do need to figure out the number of adults. So if s is equal to 400 and we have our equation for adults, right? It's 120 plus s. I can just go ahead and replace this s with 400. So 120 plus 400 is 520. So there are 520 adults. And this makes sense to me because there are 120 more adults than students. Just do 520 minus 400 and you get 120.